up, friends? Thanks for joining us today for ordering real numbers. This is going to be very similar to the ordering rational numbers lesson, which you can also find on this page, but this is going to be more challenging. It's going to have more negative numbers, it's going to have square roots, and the pi value, which is what makes it real and not just rational numbers. If you haven't already, go ahead and print out the Teachers Pay Teachers resource that you can follow along and internalize, and it'll help you feel super confident in teaching this lesson. This is going to be an 8th grade TEK. In Texas, it is 8.2D for those of you in Texas. And again, thanks so much for coming. I hope this is really helpful for you. Happy teaching. Let's get started. Today, students are going to order real numbers from mathematical and real world contexts. So the first thing you're going to do is you're going to have students just do a quick refresher to say, what do I remember about the words that I'll see coming up in the word problems? There's my cat. The first thing that they're going to do is they're going to circle the words that mean the biggest number. And then I'm going to box the words that mean the smallest number. This is just a good refresher. Spaghetti. Out. All right, so give them 1 minute to do that and come back and we'll check their work. All right, here are the answers for this one. You'll see that I circled the words largest, greatest, biggest, and this is tricky for kids because when kids see fastest, they often think that's the biggest number, but when you see like racing questions, you'll see a lot of like track and car racing questions. The fastest number is actually going to be the smallest number, so that means the slowest number will be your greatest number. So on the opposite side, we have least, smallest, and fastest. My cat has decided to join us. All right, the next thing we're going to do, spaghetti. Get out of here. Okay, the next thing you're going to do is you're just going to give the kids an opportunity to kind of like get their brains working. Kids need a little refresher and to feel successful at something the first time. So you're going to have them just for 3 minutes on their own do the following warm-up. You're going to have them order the numbers, these graduated cylinders from biggest to smallest, biggest being 3, smallest being 1. Then you're going to have them simplify these numbers here. If you need to do a quick refresher on perfect square roots, you can do that there, and a quick refresher on dividing fractions to decimals, and then we're going to order these from least to greatest. So I'd give kids right now just maybe 2 minutes on their own to work independently and silently, and then you can give them a minute to work with a partner, and then we'll come back and check our work. Okay, here are the answers for the warm-up. I think this is a great opportunity to connect students what they learn and what they see in science. You'll see the answers here. Those are pretty straightforward. This is a great refresher if they need to be reminded about square roots. And these are perfect square roots, so these are pretty easy here. And I think it's also a great reminder to show them if I have a fraction that doesn't simplify nice and neat, then I will have to divide my numerator by my denominator. Here's the work that I showed, and I included my decimals. That decimal is extra big, super fun. Now I underlined here least to greatest. We want to get kids in the habit of doing least to greatest, and then I have the most negative numbers that are the least, and my bigger numbers are on the right. So those would be the answers to check here. The next thing we're going to do with students is we're going to have them plot the following numbers on the number line. Then we're going to order them from least to greatest. So my smallest numbers are going to be my most negative number. So all the numbers to the left are going to be the most negative. I might do this first one for them. The first thing I'm going to do is I'm going to plot 0, 4, oh, there's not a 5, it would be here. I've got -3 and -1. So from left to right, I have -3, -1, 0, 4, 5. You can even add little commas here. Great, so I've showed students how to do the first one. Now I'm going to say, all right. Oh, you didn't see any of that, did you? Whoops. All right, moving that up. Now you're going to show students that they have to do these next two, number 2 and number 3 on their own. We'll come back and check their work, and I'm going to move my cat in the meantime. Okay, move my cat. He was not happy with me. And here are the answers to this one. You'll see that I have plotted the points on the number line. Then I've ordered them from least to greatest, the most negative to the most positive. We really want to get students in the habit of checking this in this way, and they can also make number lines too, so I think that's a great thing to show them. Okay, now that we've gotten some basic practice, and we want to show students that every time we have a set of numbers, the easiest way to compare them is we want to change everything to a decimal first. I like to tell kids it's like if I have things in a bunch of different languages, it's hard for me to compare what's being said. I need to translate it all to the same language so that I compare what's being said. So the easiest way to do this is that we're going to compare to decimals first. So this is just some basic practice. You can do this with them. I have 60% here. This is not a decimal because it has a percent sign. There's an imaginary decimal here. I'm going to move it 1, 2, move my decimal here, becomes 0.60. Then I have 4/5. That is a benchmark decimal. Should know that off the top of their head. If they don't, they can convert to over 100. That's another way to do it if students don't know that off the top of their head. If I have a fraction, I'm going to do 13 of the numerator divided by my denominator, which is 13 divided by 4. Gives me 3.25. Next, I have another percent over here. I'm going to move it 2 times to the left. This is tricky for kids because they say, oh, I have a decimal here. It's in decimal form. Nope, nope. Anytime you see a percent here, we're going to change it to a decimal, move the decimal 2 times to the left. It is a-okay that there are 3 numbers behind the decimal point. I have another fraction here, so I'm going to do, this one's actually nice and neat. I can convert this one by doing times 5, excuse me, gives me 30 over 100, gives me 0.30, or you could just do 0.3, also fine. So I have a square root here. The square root is the square root of 9, which I know is 3, but I have a negative in front of it, so I'm going to have negative 3. And if I technically want to change it to a decimal, I can add that decimal 0 behind. Does not change the value of the number. So if you do not have a calculator, I know kids can use the calculator on our standardized test in Texas, but if they can't on a unit exam or something, we want to teach them how to do this. Also, just a great thing to know, estimate the square root by comparing it to the closest perfect square. This number line I think is a great visual for them. So what we're going to do is we're just going to locate the following numbers on the number line below. I've got the square root of 1 is 1, the square root of 4 is 2, and it gives me 8 and 0 as well as benchmarks. So I'm going to fill these in here. I've got the square root of 64, the square root of 0. I'm actually going to cross these off as I go. That's just something I like to do. I know that the square root of 81 is 9. I'll keep filling it out. Okay, now that we've filled in those perfect squares on the number line, we're going to use those to locate the following numbers on the above number line. This is not a perfect square. Square root of 20 is not perfect. So I can use these square roots that I'm given to make an estimate. So if I've got the square root of 20 here, I know that's going to fall between the square root of 16 and the square root of 25. It's about halfway, not quite halfway between the two of them. So I'm going to put it about here, and it gives me about 4, I'm going to say like 4.4, because it's not quite all the way to 4.5, but it's close. Next, I've got the square root of 27 here. So the square root of 27 is going to go between the square root of 25 and the square root of 36. I know it's going to be a little bit closer to the square root of 25, so I'm just going to make an estimate that it's about 5.2. Again, not perfect, we're just making estimates here. Next, I have the square root of 32. I see that it is between the square root of 25 and the square root of 36, but it's going to be closer to the square root of 36, a little bit over halfway, so I'm going to say that's about 5.7-ish. And then I've got the square root of 18. My other cat has joined us now. These cats love math. Okay. The square root of 18 is between the square root of 16 and the square root of 25. It's a little bit more than halfway, and so I'm just going to say oh no, I've got these mixed up, silly me. It's not quite halfway here, so the square root of 18 is going to be less than the square root of 20, so I'm going to say it's about 4.2 or so. All right, now that we've had some practice converting fractions, square roots, percentages to decimals, we're going to put it all together and start comparing all the different forms now. So let's start with just an easy peasy number line. So the first thing it says is to graph the numbers here on a number line. So I'm going to start with negative 0.2, 7/10, -1, square root of 2, and -4, and I'm going to convert them to decimals as needed. This one's already in decimal format, so I'm going to change 7/10 to a decimal, which is 0.7. Then I have -1. I don't need to change that. The square root of 2, I do need to simplify that. I'm going to go back up to my number line here. I see that the square root of 2 is going to fall right about here. So I think it's going to be about 1.5 or so, 1.6, just making an estimate. And then I have -4. I don't need to change that at all here. So now let's start plotting. The first thing is -2/10. So I'm going to go -0. I've got 0 here, -2/10. I'm going to make a little arrow so that I know what I'm talking about. Okay, I'll cross it out so I know that I've done it. I've got 7/10 here, which I know converted to 0.7 or 0.7, 7/10. Going to be about here. These cats. Next I have this -1, so that's easy peasy one. I've got the square root of 2, which I said was about 1.6. So square root of 2. I forgot to do this one, -1. And then the last one I have is -4. And all my numbers are now graphed on the number line. If they were to ask me to order it in a certain way, it would be from least to greatest or greatest to least. All right, the next thing I'm going to get students to do is to just do some more practice of converting fractions, percentages, to decimals, and also integrating some integers, which starts to be more complicated for students. So I'm going to model for students here, and this is going to be my teacher model, of how I would convert these to decimals and then compare from greatest to least. I always want to identify what the question is asking me. So the first thing I'm going to do is I'm going to write my numbers in the table here. If you don't have a table, you should tell students you should definitely make a table. It's a very easy thing to make. It helps keep your work neat and organized. The next thing I'm going to do is I'm going to convert everything to a decimal. Now that I've converted everything to a decimal in this column here, then I'm going to line them up and start comparing from left to right. I've lined up my numbers with my decimals here. I'm going to make sure that they all have the same amount of place values after the decimal, so I added zeros, which doesn't change the value. The first thing I'm going to do is I'm going to go from left to right to compare from greatest to least. So the first thing I actually notice though is that I have a negative sign. I only have one negative, so I know that's going to be my smallest value. I have -0.75. Written originally it was -3/4, so I actually know that's going to be the last one. And I'm going to cross this out. Okay, with the ones that I have left, I'm going to go from left to right. So 0, 0, 0. I've got 7, 7, 0. Oh, I actually know this is going to be the smallest one next, since it has a 0. So I'm going to write that in its original form, 0.078, because it's the smallest as well. I only have 2 left. I know this has, oh no, I have 3 left. Whoops, which one did I forget? No, that's right. This has an extra line. Whoops. Then the next thing I'm going to do is I'm saying, okay, which one's my biggest one, 6 or 3? So 0.76, which was 76% here. And then I have 0.73. So now I have the biggest to the least negative, to the least value, which was my negative number here, like that. Next year, we're not going to have kids do this next one with a partner. I think would be fine. You're going to have them do it from smallest to largest. You can give them 3 minutes or so, circulate to check that they're filling in the columns correctly, that they're lining up their numbers, and they're ordering from smallest to largest, and then you can give feedback and check at the end. All right, here are the answers for that second practice problems with kids. I think this one's pretty straightforward. It does give you the opportunity to talk about negative values again, how the greater negative they are, actually the smaller number that they are. Next, you're going to move to a teacher model. I'm going to teacher model this one for you so that you can do it for students. The first thing I'm going to do is I'm going to read the question. Students in Ms. Baker's class must complete at least 40 math problems for homework every week. The table below shows the progress of 4 students on Wednesday, which list shows the amounts of homework completed in order from greatest to least. All right, so I know I'm answering from greatest to least, and I see I have values over here that are not all in decimal format, so I'm going to do that first. So I have Katie, she's already in decimal format. I don't need to do anything with that. D'Angelo here, he is going to need some work because we need to simplify this. So actually I would simplify this first. I would do 45 over 40, which gives me, I'm going to simplify both of these by 5, and that gives me 9 over 8. Not a beautiful fraction, but I can do 9 divided by 8 here, and that's going to give me 1.125. So I'm going to write that next to his, 1.125. I know that means that D'Angelo has done more than how much homework that he needs. He's done more than 40, so that is good to know. Grace has done 100%, meaning she's done 40 problems. Great for Grace. I'm going to change this 100% to a decimal, which will just be 1, 0, 0. Okay, and last we have Jonah. He's done 2/3. That's a benchmark fraction, which converts to 0.66 repeating. I'm going to go ahead and write this just because it makes me feel better. Okay, I've got all these here. So now I need to know from greatest to least who has done their most homework and who has done the least homework. So I'm going to compare these numbers here. I see that D'Angelo has done the most homework because he's done over 1 whole of his homework. So D'Angelo is 45 over 40. Oh, I see that only one answer is 45 over 40, but let's double check. Then we have 100% Grace. Yep, that's next. Then I have 2/3 of Jonah. And then last I have Katie, who has only done 4/10 or 40% of her homework. So I'm going to circle answer choice B that shows from greatest to least. So the first thing I'm going to do is I'm going to read the question. Tiffany, Michaela, Taylor, and Carol measure the distance given in the table below. Order the distances from shortest to longest. So the first thing I'm going to do is I'm going to identify, I'm going to go from shortest to longest. So in my head, I'm going to go from least to greatest or smallest to biggest. The first thing I'm going to do is I'm going to convert all of these to the same format, which I'm going to choose as a decimal. I'm going to divide 131 divided by 8, which is going to give me, I'm going to save you all the math on that because that is not super fun. And that's going to give me 16.35. Alrighty. So next I'm going to convert Michaela's, which is 33 over 2. And that gives me 16.5. I'll start label these as well. I've got Tiff. I've got Michaela. Next I'm going to do Taylor. Taylor is the square root of 115. I know that the square root of 115 falls between 2 perfect squares of square root of 100 and the square root of 121, which is 10 and 11. So 115 is going to fall almost at the middle of that. And so I'm going to say that this is about 10.4. All right. And then last but not least, we have our friend Carol. Carol has 2 times pi. When I see a number next to a pi, that means, or next to a variable, in this case it's pi, no, I need to multiply. So 2 times, and we're going to say 3.14 is 6.28. Okay, so now we need to find the shortest number to the longest number. I know that Carol has the smallest number here, so I'm going to start with Carol because she's the smallest. I'm going to cross her out. Next, I have Taylor. She has 10. I'm going to cross her out. Then I have Tiffany. And last, we have our girl, Michaela. And that's how you order sets of real numbers, by converting and then comparing. Okay, now you've modeled a lot for students. You've given them a bunch of examples. Now it's time for them to work with a partner. The first thing you're going to do is you're going to make sure that they are set up with criteria for success. The criteria for success here is as follows. First, they're going to read the question, annotate the question to determine what it's asking you to do. Greatest to least, least to greatest, so on and so forth. Then I'm going to simplify the square roots and convert all numbers to decimals as needed. Then I'm going to make sure I show all my work. I'm going to eliminate answer choices when possible, and then I'm going to check my work. I would give kids about 3 minutes per question. There are 3 minutes here, and then about a minute of buffer time. So I'm going to say you have 10 minutes with your partner. I need to see all the things on your paper. If you're stuck, ask a friend. If you're still stuck, ask me. You're going around and giving them pen to paper feedback, and then we'll come back and go over the most missed answers. All right, here are the answers to the partner practice. If you'll notice here, I did do an oopsie and I messed this one up here, but if you download the resource on Teachers Pay Teachers, it will definitely be fixed. So I'm so sorry about that. I'm just a human, please forgive me. So I did want to point out here on this one, this is the one I was talking about with the ordering from the fastest to slowest. This means that this is going to be the smallest numbers, because if someone's traveling the fastest, their number will be smallest. All right, and the very last thing you're going to want to do is you're going to want to get kids doing this on their own. You should reference again the criteria for success that is listed on the partner practice page. I would give them, again, 10 minutes work independently and silently. You're going around checking their work pen to paper so that you can see how they're doing, and then you can go over any trends after they're all done. Okay, after you've given kids about 10 minutes to work on their own, you can show them these answers here. You can go over trends that you saw as you circulated. Something that I noticed when I was working is that I needed to make sure that my work was neat and organized. So make sure that your kids are doing that, because it really helped me. And I've been a teacher for a long time. So these are the final answers here. Hopefully your kids feel super confident. Even if you need another day at this, that is okay. Thank you so much for joining us on Hello Math Friends. Can't wait to see you next time. Happy teaching.